Hey, in this one I wanted to quickly present the cpptrace library, which helped me a lot when debugging C++ crashes or errors or things like that. Basically, it's a way to just have a traceback whenever you have an error or just whenever you want in C++, which is really handy because, obviously most programming languages have that built in nowadays, but C++, like in C++23, they're starting to add stuff like this, but it doesn't work too well and so on. So yeah, for now we have a library. So anyway, here I have a little program that calls a main that calls the function foo, that calls the function bar, and in the function bar I print the file and the line number, like so, and it works. But of course, to get like a stack trace, you would have to parse the stack and so on, which is annoying. So of course there is a library for you to do that, which is called cpptrace. You can I'll link the README for you to see how to install it and so on. It's not it's quite easy, and you just need to link also the library cpptrace and have debugging symbols when you compile your executable. But after that, what you can do is replace your ugly file and line number with cpptrace generate trace, like so, and then just print it up. And you will see right away that we have something that is quite nice out of the box, that just shows you which functions, which file, which line number, which column, and so on and so on. And so on its own, it's not just like this, it's not super impressive. But what you can do is whenever, now let's say that I'm throwing an exception, if I can spell it throw, runtime error, hello, up. By default, it would just do this, and I think on some platform it doesn't even do that, which is, I mean, decent, I guess, but not very helpful. And what you can do is you have you can include the cpptrace from current header, and then you can do cpptrace try, like so. Basically, they have a try catch wrapper in which you can put your code that might or might not crash, and then cpptrace catch, like so, and then basically it's whatever you would put in the catch, exception, like so, and here you can do now cpptrace from current exception and then print. And instead of having this ugly message, you have a literal traceback of where the exception happens, which is in bar line 7. I mean, there is a bit of junk before it, but otherwise you get your usual traceback, but for an exception, which is a far jump, which is awesome. I don't know how they figured that one out, but it's pretty impressive. You can also use, so there is this function called std terminate, which basically is kind of a wrapper around the abort function, but except it has a handler that you can set with std set terminate, and you can have a function to call before terminate, before doing abort. And of course, if you just call std terminate on its own, it just says, oh, terminate, it did basically abort it. But cpptrace has a little nice little helper function where you can do register terminate handler, which will basically set the terminate handler for you. And again, it will just print a traceback of where the std terminate happened. And that's very useful because a lot of standard library functions or method use std terminate in like very bad cases, or I think maybe when they assert stuff or things like that. I'm not entirely sure. But it has happened to me quite often that terminate is called, and cpptrace prints me a traceback, and it's super useful to see which function caused some library to call terminate. So yeah, that's mainly the use case for it. I also have an example which I haven't tried like in real code or whatever, but when looking for information for this video, I stumbled upon it. It seems quite interesting, but a bit too involved for me to added to my code base yet, but basically you can also print a traceback, but for a backtrace for the segfaults, which seems super useful, or like a segterm or whatever. Segterm, actually, I'm not sure, but segfault definitely. So I've basically this is code that I copy pasted from like the README. So yeah, I don't know much. From what I understand, they're trying to like a lot of stuff can go wrong if you do too much, let's say, shenanigans in a signal handler. So like they do stuff like whenever the signal handler for segfault is called, they spawn another executable, create a pipe, and forward like the trace back information through this pipe to this spawned executable. Anyway, very interesting stuff, but I don't understand much of it. But anyway, they do a lot of things, and you can see that they have a pipe, they write to the pipe, they get like the object frame, they get the frame and they read them to the pipe, write them to the pipe. And then they have a handler which, I don't know, calls this function and generates row trace thing. They have also, I don't know, a warm-up function. I don't know what most of this does, but it's kind of cool. But anyway, in the end, you register your handler with segaction. And here I have my little code which will generate a segfault with a null pointer dereference. And there is also this tracer program, because of course the little child executable, child process they spawn needs to come from somewhere, and this is just literally, I don't know, your executable spawns another executable, which is kind of funny just to print a traceback, but oh well. Anyway, you have to compile this little tracer program, which I have already done. So here I have my signal tracer. Oops, maybe my camera is hiding this. I have my little signal tracer executable. And so now if I do G++, think I have to find it. Well, I guess I can use the previous one, this. And instead of this, I want to do my segfault example. Let's do segfault example, like this. And now if I run my segfault example, you can see that, yeah, I segfaulted, so my program terminated, but I got a traceback to like the exact line where it happened, which is 83, and indeed it happened at 83, which is kind of crazy to me. But yeah, that's really cool library. And well, the segfault stuff is more like more advanced than for me to use it. But like the things I showed earlier with like the simple exception catching and like the std terminate catching and just having a traceback whenever you want is super neat and really, really easy to set up. So yeah, I hope it will help you catch some more errors in your C++ programs, and see you on the next one.